First, I'm going to explain the K-mean algorithm, and then we're going to have some examples and making a conclusion of how it works. First, we have an importation of our libraries. In this case, the only difference is sklearn to make the blobs. First, we generate our synthetic data. In this case, we have a number of samples, a number of centers, and a cluster standard, and a random state. After that, we have a calculation of the distance by making a euclidean distance from A to B is the square root of a sum of the uh, power of the difference between A and B. After that, we have to initialize our centroids randomly. We use, in this case, a random seed. And in this permutation, we have the centroids, the first centroids that we want to observe. After that, we have assigned clusters in which we have an average of the distance between a point and a centroid, in which we make them uh, the closest centroid. After making assigning the points to the closest centroid, we go to the calculation of the new centroids. In this in this new part, we define the new centroids by collecting all the points assigned to a cluster. Then we compute the average position of these points, and with this average, we become a new centroid. In this part, we update the k-means or the centroids. After that, we have the full k-mean algorithm that is initializing in all the centroids, and we repeat the part of assigning each point to a nearest centroid, update the centroids by the average of the assigned points, and we stop early if the centroids are no longer changed, and we return the final centroids and clusters assignments. After that, we run the algorithm in this part by defining the number of k-means. In this case, we're going to see the the centroids as the amount 6, and after that we have the visualization part that is the two parts of a table. First, the random initialization, and after that, the supposed means. We're going to see in this case we have 1,000 samples, 6 centers, and six centroids. We can see the clusters and our first centroids, and after making the new centroid calculation, we can see that it's pretty close to what we can expect. The green part on the right is a big amount of points away from the other groups. If we make this number smaller, we can actually see a better image. Let's make more centers, and we can change the amount of means by 1. Let's see. We can assume that by having a low amount of data but increased number of centers and centroids, we can understand the average from each cluster. It's pretty close in this case. I think that by being away from the other points, this yellow section can be not represented correctly as an average, and it's understandable because by having a bigger k-mean or centroids, we can underestimate the average, and as well, if we have a low amount of centroids, we can make a big difference between one and other group of points. Let's see if I make this a two centroid analysis. We are going to have centroids that may look pretty uh, different as we expected. In this case, I think that 1, 2, 3, 4, 5, 6, 7, 8 centroids might be the better solution. Okay, thank you.